Hello friends, welcome again. And today we'll be solving a problem related to signaling system. And the problem is as follows. It says what is the value of sigma n equal to 0 to infinity and 0.5 raised to the power n. So how to proceed for this kind of problem? Here if we know some of the properties of Z transform that will come very handy to us. So let us say x of n has a Z transform of x of z, then we know that nx of n has a z transform of minus z dxz over dz. Okay, this is a property which should be known. Okay, now what we can do is we can just write the definition of nx of n. Okay, if I write the z transform definition of nx of n, what it will be? So I can equate this to sigma n equals to minus infinity to infinity. Okay, nx of n, okay, z power minus n. Now you can see there is some relationship building here between these two. You can see that the limit is from minus infinity to infinity, so the limit has to be made from 0 to infinity. Okay, and if we compare these two, what we see is if we put z equals to 1 here, we can get a similar expression where x of n may be same as 0.5 to power n. Okay, and also to make the limit from 0 to infinity, it should have u of n with it. Okay, so if we compare these two expression, what we are going to get is uh, x of n should be equal to 0.5 power n, and there should be u of n. Okay, so that we are able to make the limits from 0 to infinity. Okay, so this u of n has come so that the limit is from 0 to infinity. You have to be very careful here, and this is how it is going to be. And uh, what we can now do is we can simply find our z transform of nx of n. Okay, now that is nx of n is n 0.5 power n u of n. This is our nx of n. Now we know that z transform of x of n, okay, x of n is equal to, which is a z transform of say 0.5 power n u of n, which we already know. Okay, this is the basic z transform that we always remember, which is 1 over 1 minus zero point 0.5 z inverse. Okay, this is what we know. Now we need to find the z transform of nx of n. So how to proceed for that? So you know that z transform of x of n is known to you, which is 1 over 1 minus zero point 0.5 z inverse. Okay, now z transform of nx of n, okay, is minus z d by dz of 1 over 1 minus zero point 0.5 z inverse. Now if you differentiate it once, then what you're going to get is 0.5 z inverse over 1 minus 0.5 z inverse raised to the power 2. Okay, so this is what you will get when you do the z inverse. Now what we can do is we can simply write the definition of nx of n. So definition of nx of n will be sigma n equals to minus infinity to infinity n x of n, okay, z power minus n. And now we know this z transform is 0.5 z inverse over 1 minus 0.5 z inverse whole squared. Okay, this is what is known to us. Now you can substitute what is your x of n. So this limit is going to be from 0 to infinity now, 0 to infinity. Okay, and 0.5 power n, okay, z power minus 1 is equal to 0.5 z inverse over 1 minus 0.5 z power minus 1 whole squared. Okay, so now what you can do here is to make this expression as this. Okay, you can substitute z equal to 1. Okay, so we'll write put z equals to 1. If you put that, then you get n equal to 0 to infinity n 0.5 power n, okay, is equal to, now you put 1 here, So you get into 1 inverse, which is 1 over 1 minus 0.5 into 1 whole squared. Okay, so this is 0.5 over 0.5 whole squared, which is 1 by 0.5 and which is equals to 2. So what you get is 2 as your answer. Okay, so this is how you can proceed for the problems where you can identify the property of Z transform or any other transform to be used. So thanks for watching.